Hello everyone, second part today concerning the use of the tb-deco ATV 2017 software. In the first software, what we saw concerned some of the settings of the software. Today we are going to focus on the programming of this piece that you can see on the screen. It's a very simple piece, an axis taken from a brass bar of diameter 20. It is 13 millimeters long with two detailed diameters, one of 10 and the other of 15. And also angle breaks from 0.2 and 0.5 to 45 degrees. So I decided to do 7 tutorials concerning this piece because each time I'll be adding an additional operation. In the third tutorial, we will see, in addition to the turning of this piece, its combing, which will be carried out on a diameter 10. In the tutorial 4, we will also add drilling at the end with axis X3, Z3. In the fifth tutorial, we will add milling, which will be done on the diameter 17. It will be a flat which will be realized with the X2, Y2 axis. In the sixth tutorial, we will also add a transverse drilling still with the X2, Y2 axis through a diameter 10. And finally, in the seventh tutorial, we will see the drilling that will be made in a counter operation with the X4, Z4 axis. So that's it for the next tutorial. We will focus today on the programming of this piece. To make this part, we are going to use 3 tools, which are going to be the T221 for roughing. We are going to use the tool T15, which will be for the finishing tool, and the tool T11, which will be a cutoff tool. So you go here to the tool catalog, which is up there, fill in a certain number of parameters. We can see that there are already tools that are pre-programmed in the software. In particular, we find here the cutoff tool T11 with standard geometries. A standard geometry here, for example, in Z0, which is native 20, corresponds to a right-hand cut. Normally, we will use a left-hand cut, which means we will have to shift this geometry here to about negative 40. For me, it is minus 40. Also enter the width of your tool, which here will be 3 millimeters, and the tip height of 0.3 tenths of a millimeter. Confirm with OK. We will now take care of the roughing tool, which is the T21. It is present here with pre-programmed geometries that we will leave as is because for the moment they suit us quite well. We are simply going to fill in here the radius, which is 0.4 millimeters, and the quadrant 3, which is already done here, and it suits us well. The finishing tool, which is not listed in the catalog, we decided to use the T15 tool. So click up here on this little T, which is up there in this window. You are going to fill in the number of your tool, which is 15. This will be the turning tool, an external turning tool, and you validate by OK. Parameters are also already pre-programmed. We will leave them by default. But here we are going to add for the finishing tool a 0.2 millimeter insert radius, and we are going to need to insert the tool quadrant, which is quadrant 3. Validate by OK. The tool catalog here being finished. On the other hand, for the T15, which is the geometry of the pad manipulator, which at the 150 millimeters, we will have to change this geometry because it corresponds to the geometry for gripping pads with tweezers. We decided to use the basket and the pad extractor, which is in the counter spindle. So here we will end up with a geometry of about 330 millimeters. Validate OK, and that's it for the information of the tools in the catalog. Now that the catalog is finished, we are going to enter the programming of the piece. Just a little information before programming this piece. When you are going to use this tab here, which is the tab that corresponds to adding of icons in your operations list. For example, by clicking and dragging here the icon between 1.4 and 1.5, you may notice that it is not numbered automatically. This should not be a problem, but for the understanding of the program, it is better that your operations lines are well defined, and this also avoids you to have to come back here to renumber every time. So in order to renumber them automatically, you can modify the configuration of the program by clicking on options configurations, and by going with this little arrow at the very end of the others tab, which is here. Here you can renumber the operations automatically just by clicking on this case. It's very easy. You have to know that, and it helps you save time by not coming back to operations every time. So now that you can, when you drag a new icon between the tools, for example, your tools will be numbered automatically, which makes the program much easier to understand. Here's a little information just before you start programming. So we're going to position our icons in our operations lines here. In COM2, we have in 2.1 an indexing of our roughing tool. In COM1, we are going to add the indexing of our finishing tool in 1.6. We are going to position our bar at 2.2 millimeters so that we can engage in 2.2 our roughing tool. We will start by turning simultaneously, then we'll therefore draw a link between icons 2.2 and 1.7. In 2.3, we will release the tool after turning of diameter 10, and we'll draw a link between 1.7 and 2.3 to finish in 1.8 to complete the turning of this piece. We will therefore draw a link from 2.3 to 1.8. So here in icon 1.5, we are going to engage our finishing tool. Indexing finishing T15, we're going to fill in the turning icon G1, G100, X35, Y1 equals 0, T15. I then delete in 1.6 and we'll position our bar at 2 minutes so that we can be able to engage our roughing tool on the diameter 12. Here in 1.6, so we have G1, G100, Z1 equals to T15. Validate it. In 2.2, we'll engage a roughing tool on a diameter of 12. Roughing T21, G1, G100, X2 equals 12, T21. Then in icon 1.7, we are going to start our turning simultaneously. Finishing T15. With its indexing as follows: G1, Z1 equals 0, F 0.06, T15. To referencing of diameter 21, we have G1, X1 equals 21, G100, start cutting move, G1, X1, F006, and we will go below the 0 to remove any trace of burr. G1, X1 equals -1, F 0.03. We are going to start the turning of the diameter 10 over a length of 8 millimeters to be able to engage our roughing tool and finalize the turning of length. So we have G1, X1 equals 10, F 0.08, G27 with a chamfering of 0.5, L equals -0.5, and a feed of 0.0302 on 8 millimeters. I have G1, Z1 equals -8, F 008. That's it for this icon. In icon 2.3, we will release our roughing tool because we don't need it anymore. So here roughing release T21. I delete the Z, G1 X2 equals 21, F 0.2, T21. And undercut G1, G100 X2 equals 35. I validate. Then in icon 1.8, we will finalize the total turning of this piece. Let's finish T15. So here we are going to finish the diameter 10 with a length of 8 millimeters. G1 Z1 equals negative 8.5, F 0.04, T15. We are now going to mount the diameter 15 with a chamfer of 0.2. G1 X1 equals 15, F006, G27, L equals 0.2, and then we are going to turn this diameter 15 on a length of 11 millimeters. G1 Z1 equals negative 11, F 0.06. Now we are going to mount a diameter of 17 with a chamfer of 0.2 as well. G1 X1 equals 17, G27, L negative 22, E 0.02, and we are going to finish the turning on a length of 14 millimeters. G1 Z1 equals negative 14, F 0.2. And now we will release our finishing tool. G1 X1 equals 21, F 0.08, X equals 35, and that's it for turning. So let's summarize. Here, the indexing of our finishing tool in 1.5, in 1.6, positioning of our bar at 2 millimeters to be able to engage the roughing tool in 2.2. So here we have G1, G100, Z1 equals 21, T15. In 2.2, we engage our roughing tool on a diameter of 12, G1, G100, X2 equals 12, T21. And not to forget here to delete the Z axis, otherwise you'll find an error. In 1.7, we are going to start in simultaneously turning of a diameter 10 over a length of 8 millimeters. J1 Z1 equals 0, F 0.06 to be able to cut through the element. We have G1 X1 equals F006 is the phasing of our operation of our piece, and we'll go below the 0 to eliminate every bar. G1 X1 equals 10. We have brought our tool to a diameter 10, and we are going to be able to start the turning of the diameter 10 over a length 8 millimeters so that we can release our roughing tool. In 2.3, we will release our roughing tool at diameter 21 and then release it completely at diameter 35. And in 1.8, we are going to finalize the turning of our piece. So we finalize the diameter 10 on the length 8.5. Then we are going to turn the diameter 15 with a chamfer of 0.2 at 45 degrees on 11 millimeters. Here we are going to turn the diameter 17 also with a chamfer of 0.2, and then we are going to turn this bar on a total length of 14 to clearance and finalize our turning. We are now, since the program has finished generate our piece with this icon. So here we have an error message which tells us that we have resource incompatibility with operations 3.3 and 1.7. So why is it here? That's because in 1.7 we haven't removed Z1 since we are using it again, and in 3.3 we have the main axis which is still engaged. So we are going to have to add an icon here while deleting Z1, and we are going to indicate that it's a comment. which as such you find an icon with a slash, which tells us that there is no inner operation. We validate again these operations, and that's it. Our program is apparently functional. We have here in this icon to check the movement of our axis. Let's start reading here. So here you can see that the movements are a little bit slow, since we certainly forgot to start here to trigger in the program the energy optimization. At first, I advise you not to disable this energy optimization. It is worth using it when you have long series to be able to optimize the maximum loss of time. When you have small series, I advise you not to use it because you may have a little bit of surprises. That's it for the programming of this piece. I'll see you next time for another tutorial. Thank you for your time.